Now let us discuss the homogeneous higher order linear ODEs with constant coefficients. So consider the nth order homogeneous linear ODE with constant coefficients as y raised to n plus a n minus 1 y raised to n minus 1 plus etc. a naught y equal to 0. Here y raised to n and y raised to n minus 1 are the corresponding derivatives of y. Okay, and a naught a1 etc. a n minus 1 are the constant terms. Now corresponding to this equation we'll get a characteristic equation or an auxiliary equation like this by replacing the capital D by lambda as like the second order. So the auxiliary equation will be lambda raised to n plus a n minus 1 lambda raised to n minus 1 plus etc. a1 lambda plus a naught equal to 0. Since it is an nth order equation, it will have n roots. So the n roots, let the n roots be lambda 1, lambda 2, etc. lambda n. Now, depending on the nature of these roots, there will be 4 cases arising for the general solution of the given differential equation. If the lambda 1, lambda 2, etc. lambda n are real and distinct roots, then its general format will be y equal to c1 e raised to lambda 1 x plus c2 e raised to lambda 2 x plus etc. cn e raised to lambda n x. Okay, we have already discussed the roots with the two roots, the second order equation with the two roots lambda 1 and lambda 2. In that case we got the general solution as y equal to c1 e raised to lambda 1 x plus c2 e raised to lambda 2 x. Here we have n roots, so extending this format up to nth term, that is cn e raised to lambda n x. Okay, next case, if the three of the roots are similar, real roots at the same time, the three of these roots are same. Lambda 1, lambda 2 and lambda 3 are same roots, say equal to lambda, and the remaining other roots, lambda 4, lambda 5, etc. lambda n are distinct real numbers. In that case, the general solution format will be y equal to c1 plus c2x plus c2x square e raised to lambda x plus c4 now the remaining roots are real and distinct, so the first case can be followed. C4 e raised to lambda 4x plus c5 e raised to lambda 5x plus etc. cn e raised to lambda n x. For the first case, if lambda 1 equal to lambda 2 equal to lambda, two of the roots are similar, we got the general solution as c1 plus c2 x e raised to lambda x. So here three of the roots are similar, so extending up to one more term, c1x plus c2 x plus c1 plus c2x plus c3x square into e raised to lambda x. Now the remaining terms can be written as like this. Okay, now the next case, if the roots lambda 1 equal to alpha plus I beta, and if the roots lambda 1 equal to alpha plus I beta, lambda 2 equal to alpha minus I beta, and the remaining roots are real and distinct. So two of the roots are complex. So if the roots are complex, we can use this format y equal to e raised to alpha x into c1 cos beta x plus c2 sin beta x. And the remaining roots can be written as like this, and that which is followed by the case 1. Okay, then the last case. Now the last case, if two of the roots are similar complex numbers, like if lambda 1 and lambda 2 are equal to alpha plus I beta and lambda 3 equal to lambda 4, which is equal to alpha minus I beta, then the general solution and all the rest of the rest of the roots are real numbers. In that case, the general solution is of the form e raised to alpha x into c1 plus c2 cos c2x into cos beta x plus c3 plus c4 x into sin beta x, plus the remaining roots will be of the form the real number, so it will be c5 e raised to lambda 5x plus etc. plus cn e raised to lambda n x. This is the last case. Next we move on to the problems. First solve the differential equation y triple dash plus 9y dash equal to 0. The procedure is same as the second order type differential equations. So replacing the dy double dash by d cube y and y dash by dy, and taking the common y as common outside, we will get d cube plus 9d of y equal to 0. Now the auxiliary equation can be formed by replacing d by lambda. So the auxiliary equation is lambda cube plus 9 lambda equal to 0. Using factorizing, we will get three roots: lambda 1 equal to 0, lambda 2 equal to 3i, and lambda 3 equal to minus 3i. So two of the roots are complex roots and one is real root. So one root is real and other two roots are complex number. So we can use the form. For the real root, we will use c1 e raised to lambda 1 x. So replace this lambda 1 as 0. So we get c1 e raised to 0 x plus, next two of the other roots are complex roots. So which is of the form e raised to alpha x into c2 cos beta x plus c3 sin beta x. Here this is a complex number which is of the form alpha plus I beta. So the value of alpha is 0 and value of the beta is 3 here. So we will get e raised to 0x into c2 cos 3x plus c3 sin 3x. Value of e raised to 0 is 1. So we get y equal to c1 plus c2 cos 3x plus c3 sin 3x. Next problem, y raised to 4 plus 16y double dash equal to 0. Y raised to 4 means the fourth derivative of y. So we can replace it by d raised to 4y plus 16 d square y. I am taking y as common outside, we will get d raised to 4 plus 16 d square y equal to 0. Now to find the auxiliary equation, replace the capital D by lambda. We will get the auxiliary equation as lambda raised to 4 plus 16 lambda square equal to 0. Using factorization method, we will get the roots as lambda 1 equal to 0, lambda 2 equal to 0, and lambda 3 equal to 4i, and lambda 4 equal to minus 4i. So here two of the roots are real and same, and other two roots are complex numbers. So the solution format will be of the form, for the same real roots we will get c1 plus c2x into e raised to 0x, and for complex roots the value of alpha is 0 and beta is 4. So e raised to 0x into c3 cos 4x plus c4 sin 4x. So we will get y equal to c1 plus c2x into c3 cos 4x plus c4 sin 4x as the general solution for the given differential equation. Then next problem, d cube minus d square minus d plus 1 of y equal to 0. Here directly we have given in this format, so we can directly find the auxiliary equation by replacing the capital D by lambda. So the auxiliary equation is lambda cube minus lambda square minus lambda plus 1 equal to 0. Using factorization method, you will get the roots as lambda 1 equal to 1, lambda 2 equal to 1, and lambda 3 equal to minus 1. So two of the roots are same here. So the general solution format will be y equal to c1 plus c2 x into e raised to lambda x, plus the other root is real and distinct one. So c3 e raised to lambda 2x. So they replace this lambda 1 as 1 and lambda 2 as minus 1. We will get the general solution as y equal to c1 plus c2 x into e raised to x plus c3 e raised to minus x. Then the next problem, y raised to 4 plus 2y double dash plus y equal to 0. For finding the auxiliary equation, replace the y raised to 4 as d raised to 4y plus 2 into y double dash can be replaced by d square y, and y is same as above equal to 0. And taking y as common outside and replacing the capital D by lambda, we will get the auxiliary equation as lambda raised to 4 plus 2 lambda square plus 1 equal to 0. So for finding the roots, either we can directly use calculator for finding the roots, otherwise we can use this method. I am taking the lambda raised to 4 as lambda square the all square. Okay, and replacing the lambda square by t, we will get an quadratic equation t square plus 2t plus 1 equal to 0, which is the expansion of t plus 1d all square. So the roots will be so it can be factorized as, or it can be written also in the form t plus 1 into t plus 1 equal to 0. Now I am replacing this t by lambda square since we have assumed so. So lambda square plus 1 into lambda square plus 1 equal to 0. So we get lambda square equal to minus 1 and lambda square equal to minus 1. So we will get lambda equal to plus or minus I and lambda equal to plus or minus I. Hence the roots are lambda 1 equal to I, lambda 2 equal to minus I, lambda 3 equal to I, and lambda 4 equal to minus I. This is a type of problem can be applied. The case 4 can be applied for finding the solution of this type of problems. So here two of the complex numbers are same. Okay, here lambda 1 and here lambda 1 and lambda 2 are same, and lambda 2 and lambda 4 are same. So for this case, if lambda 1 and lambda 3 are same, so we are combining it by combining those things as like this. Here the value of alpha is 0 and beta is 1. So two of the roots are combining like this. Either we can use c1 plus c3 or c1 like this. Any of them can be used. c2 plus c4, both are same. So e raised to 0x, replacing alpha by 0 and beta by 1. So we'll get y equal to e raised to 0x plus c1 plus c3 x into cos x, cos beta since the beta value is 1, plus c3 plus c4 x into sin x. Okay, here two of the roots, since lambda 1 equal to lambda 3 equal to I and lambda 2 equal to lambda 4 equal to minus I, which is of the form 0 plus I and 0 minus I. So the value of alpha is 0 here and the value of beta is 1. So replacing the alpha by 0 in the general solution format and beta by 1, we will get the general solution like this. Next one, solve the initial value problem. Y double dash minus y triple dash minus y double dash plus 100 y dash minus 100 y equal to 0, and we have some initial conditions for finding the constant coefficient or arbitrary coefficient terms. Okay, first find the general solution. The given equation can be written also in the form d cube y by dx square minus d square y by dx square plus 100 dy by dx minus 100 y equal to 0. Now d cube by dx cube is replacing as capital d cube by dx cube is replacing by capital D cube, and d square by dx square is replacing by capital D square, and d by dx is replacing by capital D, and taking the y as common outside and replacing capital D by lambda, we will get the auxiliary equation as lambda cube minus lambda square plus 100 lambda minus 100 equal to 0. Using factorization method, we will get the roots as lambda equal to 1 and lambda equal to plus or minus I10. So here the roots are lambda 1 equal to 1 and lambda 2 equal to I10, lambda 3 equal to minus I10. So one root is real and distinct, and two of the rest of the two roots are complex numbers. So the value of alpha here, the complex number, the real part is 0 and the imaginary part is 10. So the general solution format will be c1 e raised to lambda 1 x. So replacing lambda 1 by 1, we will get c1 e raised to x plus e raised to alpha x. Value of alpha is 0. So e raised to 0 x plus c2 cos beta x. Value of beta is 10. So c2 cos 10x plus c3 sin 10x. The value of e raised to 0 is 1. So this general solution can be also written as c1 e raised to x plus c2 cos 10x plus c3 sin 10x. Now we need to find the values of these constant terms c1, c2 and c3. For this we will use the initial conditions given in the question. So we have first condition as y of 0 equal to 4, which means the value of x will be 0 when y equal to 4. So x equal to 0 and y equal to 4. Substitute all these values in the equation number 1. We'll get an equation y equal to c1, 4 equal to c1 plus c2. Since the value of e raised to 0 is e raised to 0 value is 1 and cos 0 value 1, sin 0 value is 0. So we get c1 plus c2 equal to 4. Next, apply the next condition, y dash of 0 equal to 1. The value means value of x equal to 0 when the value of y dash is 1. So but we have the y as the general solution, so we need to find its first derivative. So just differentiate both side by x. We will get y dash equal to c1 e raised to x minus 10 c2 sin 10x plus 10 c3 cos 10x. Okay, since the derivative of e raised to x is e raised to x, cos 10x derivative is minus 10 sin 10x, and the derivative of sin 10x is 10 cos 10x using chain rule. Now apply this initial condition, the value of x equal to 0 and y dash of 1 equal to 1. We will get another equation, c1 plus 10 c3 equal to 1. Next, apply the third initial condition, y double dash of 0 equal to minus 299. For this we need to find the second derivative of the general solution. So differentiate this first derivative. First derivative equation with respect to x. Again we will get the second derivative equation as like this, y double dash equal to c1 e raised to x minus 10 c2 cos 10x minus 100 c3 sin 10x. Now replace x by 0 and y double dash by minus 299. We will get another equation, c1 minus 100 c2 equal to minus 299. Okay, now solving the three equations using we got from the initial condition. Solving these three equations, we will get the values of c1, c2 and c3 like this. The value of c1 here is 1, c2 is 2 and c3 is 1. Now replace all these values in the general solution. Our general solution was y equal to c1 e raised to x plus c3 c2 cos 10x plus c3 sin 10x. Okay, so replace c1 by 1, c2 by 2 and c3 by 1. We'll get the general solution as for the given differential equation. The solution is y equal to e raised to x plus 3 cos 10x plus sin 10x. Thank you.